Hello class, in this video I'll be showing you how to write a linear function in slope-intercept form, then use the slope and the vertical intercept to graph the linear function. Let's begin. Okay, so you may recall that the slope-intercept form of a line is y is equal to mx plus b, and m represents the slope of the line, and b represents the y-intercept, which I will label as 0b. Okay, so let's take a look at an example. We want to graph the linear function, negative 3x minus y is equal to 2. And to do that, I'm going to write this equation in slope-intercept form. So I'm going to add 3x to both sides. Next, I'm going to divide all three terms by negative 1. So the slope-intercept form of this line is y is equal to negative 3x minus 2. So the slope, in this case, is going to be a negative 3, because that is the coefficient of x. So again, the slope is negative 3. The y-intercept, or the vertical intercept, is negative 2. So here we have b is equal to negative 2. So that implies that the vertical intercept is 0, negative 2. Okay, now to use the slope and the vertical intercept to graph this linear function. So I'm going to start by labeling the vertical axis and the horizontal axis. And we know that the vertical intercept is 0, negative 2. So I'm going to place a coordinate right there now. From the coordinate 0, negative 2, the slope says to find the next point, we have to go down 3 to the right 1. Okay, so from the vertical intercept, I'm going to travel down 3 units to the right 1. That coordinate will be right here. Down 3 to the right 1. And if we try to do that same pattern again, we'll be off the grid. So from the y-intercept, I'm going to go up 3 to the left 1. So this is the same as up 3 to the left 1. Now I'm going to connect those 5 points with a nice straight line, like such. And we want to give that line arrows to mean that the graph extends in both directions forever. Okay, now just to make sure that this line is absolutely correct, what I'm going to do is I'm going to pick a random point on this graph and see if it's a solution to the given linear equation. So I'm going to check the point negative 1, 1, which is right here. So I'm going to substitute negative 1 in for x and 1 in for y. And notice that the result is a true statement. 2 is equal to 2. So now I'm certain that the line that we graphed is correct, and we are done.